Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k plus 3 is equals to k, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And here we need here I can first explain why we solve this problem for two methods. So here the reason is that if in your exam the question statement is that you need to determine the values of k. So in that case, in order to find the value of k, you need to do our first method. But if in your exam the question statement is that you just determine the solution set of this problem, in that case you move directly toward the second method. But both of these two methods are valid to solve these type of questions. And now here in the first method we find the value of k, and for this we need to take squaring on both of the sides, and when we apply squaring it will be written as k plus 3 whole square is equals to k square. And now here in the next step we need to use the nice algebraic formula. You know about that. If we have a plus b whole square is equals to a square plus 2 times of ab plus b square. So according to this, you see here this term is our a and this term is our b, and we use this nice formula. According to this formula, we write the left hand side of the above equation as this will becomes k square plus 2 times of ab. Here our a is k and b is 3 plus b square. B is 3 square equals to k square. So here we need more simplifications, and it will be written as this is k square and plus 2 times 3 becomes here 6k and 3 square becomes 9. And here we move this k square into the left hand side and it will becomes minus k square, and this whole equation is equals to 0. This is the negative term, this is the positive term are cancelled out by each other, and we get here this is 6k plus 9 is equals to 0. And now here further in the next step we need more simplifications, and it will be written as 6k equals to this is plus 9. When we move it into the right hand side it will becomes minus 9. And now here in the next step we need to divide both of the sides by 6. So when we divide both of the sides by 6, it will be written as 6k divided by 6 is equals to minus 9 divided by 6. So this 6 and this 6 are cancelled out by each other, and we get here k is equals to, here we need to cancel both of these two terms, and we get 3 3s are 9, 3 2s are 6. So we easily get the value of k is equals to minus 3 over 2. And now you see here in this method we will get this is the only one value of k, that is minus 3 over 2. And now in the next step we need to verify that is this value of k be the solution and is this value of k be the extraneous root. So for verification of this value of k we need to copy down given question statement here, and this is k plus 3 is equals to k, and here we substitute the value of k on both of the sides, and it will be written as this is minus 3 divided by 2 plus 3 is equals to minus 3 divided by 2. And now here we need to multiplying both of the sides by 2, and when we multiply both of the sides by 2 it will be written as 2 multiply minus 3 over 2 plus 2 multiply 3 is equals to 2 multiply minus 3 over 2. This 2 and this 2. So after cancellation of these terms we will get here the remaining values are, so here we get 1 times of minus 3, we get here minus 3 plus this is 2 times 3 becomes 6 is equals to here again 2 are gone and we get here minus 3. And now here further in the next step we need more simplifications, and it will be written as minus 3 plus 6 becomes here plus 3 is equals to minus 3. So here you see that both of the sides are not equal. If both of the sides are not equal, this means that the value of k is equals to minus 3 over 2 is not satisfied our given question statement. So if this value is not satisfied our given question statement, This means that the value of k be the extraneous root of the given equation. Okay, so this value be the extraneous root, and you see here we cannot get any other value of k which is satisfied our given question statement. So here we conclude about that this question has no solution in general. Okay, so we cannot get any value of k which is satisfied our given question statement. So finally we conclude about that this question has no solution, which we get here in the first method. And now we again solve this problem from second method. So in second method we need to copy down given question statement here, so that our given question statement is k plus 3 is equals to k. This is the our given question statement. And here in this method we just directly conclude about the solution set of this problem, or we directly determine the solution set of this problem. Okay, so here our second method be the very straightforward method. So now here we move toward the solution of this problem. So here we move this k to the right hand side, and you see that here k be the positive value. When we move it into the right hand side, it will becomes negative. And here we easily get the value. This is 3 is equals to k minus k becomes 0. And we see here 3 is not equals to 0. So it means that in the second method we cannot get any value of k which is satisfied our given question statement. So that here we again finally conclude about that this question has no solution because we cannot get any value of k. So this is the our final conclusion about the solution set of this problem from second method, and this is the final answer. And I hope so you like both of these two methods. But if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.